na Junjun. O, ikaw na. Bahala ka na dyan, in fairness. Okay. Oh, it looks like no, not conspicuous. Okay. Number one. Okay. So let's go back with our discussion, quantum numbers. So what is the definition of quantum number? I told you a while ago. What's that all about? Quantum numbers are numbers that determine, okay, the energy, the position, the movement, the shape, and the size of electrons in an atom. So when you mean of atom, that is a single atom referring to one element. For example, if I say chlorine, there is one atom of chlorine. So in that atom, there's a lot of electrons, protons, charges, like that. So if you mean of element, that is not composed of so many atoms. That's only composed of one single atom fixed together. Okay, that's the point. Things like that. And we have the principal quantum number. The principal quantum number talks about more on the energy level. So this is the K word in your memorization. Okay, energy level. And when we phrase that in a sentence, so we can create the definition. So energy level. Okay. Number two, we have our azimuthal number. Azimuthal quantum number, okay. But this azimuthal quantum number is not quite used for some teachers or professors all over the world. They would rather use the other one, the orbital angular momentum quantum number. Okay, but it's just the same. This is the purpose of discussion because sometimes in examination, what is the another term of the other one? And you cannot answer because you don't have an information that these are the same. So to master that to our students, really to introduce them the different names of that particular term that have the same name, right? Azimuthal quantum number, or shall we say this is the orbital, but sometimes they have to drop the orbital and then it's okay to say angular momentum quantum number, things like that. Sometimes you need to investigate. For example, if I have this source of books, let's say I have the Fredmore Orange Chemistry book, I exactly memorize the author, Mr. Fredmore. I have that in my mini library in my bag. Okay, so I have also another textbooks related to chemistry that offers, a little bit of difference with their presentation of their, or declaration of their definition. Sometimes they will drop the word orbital, and sometimes they include it. So some books are saying orbital angular momentum quantum number, and the other books also will say angular momentum quantum number directly. So what you will do in that? So focus to the main idea that is angular, okay, momentum, okay, angular momentum. Since you know already that we are dealing with quantum number all the time, right? So you need only to remember the word angular momentum and add the main idea quantum number, so that you will never be busy in thinking of other words. Because sometimes it will perplex you, it will baffle you, because you keep on thinking of another word, and it looks like not very easy to remember. You got the point, things like that. You got the point. So it's going to be orbital angular momentum quantum number, or it could be also angular momentum quantum number, right? Okay. Any questions so far? Angular momentum quantum number. Okay. Things like that. Okay. We have the magnetic quantum number. Okay, magnetic quantum number. Meaning to say, it has to do something with the law of magnetism. How it will contact, attract, or magnet. Okay, I use the magnet in an action verb because I say how it will magnet, okay, the electrons in that particular orbit. That's why magnetic quantum number. These are a lot of nouns. We use that in a sentence, it will become a verb. And it's not really intentional. The way how you talk, you will do that. Okay? You get the point? So like quantum number. So the abbreviation of number is MO, but be sure to put period at the last letter. Because if you don't put period, that would mean no or nothing or none or void. Not existent, non-existent, or whatever. You get the point. So if you say number, that is N-O. And the letter O will be a small letter O. It's not the big. You get the point. You get the point. So, capital N, small letter O. Big N, small letter O. Because capital and big are synonyms in English language. Again, big and capital would mean the same thing. If I would say big letter, that is also capital letter. You get the point? Okay, going back. And then if you say also NOS, period, that is numbers. Numbers, NOS. If you put that capital N, capital O, capital N, so it is no longer numbers. Because the abbreviation of numbers is always capital N, small letter O, small letter S, period. You get the point? So you should be clerical imperfection so that you can avoid syntax error in English language. So syntax error, it has to do something with the spelling, the punctuations, the phrases like that. And sometimes the rubric of your sentence will not be correct. Okay, especially if it is being checked by international English examination, examiners, things like that. Okay, get the point. So number 4, we have the electron spin quantum number. And sometimes also they will drop the word electron. What remain is spin. Spin quantum number, or electron spin quantum number, because what will try to have this spin are all electrons. Okay, since we mean already that we are dealing with electrons here, that's why some books will not put electron prior to spin. Things like that. And we need to understand these changes. Because sometimes we will become wrong in our answers in the future examination. Sometimes you will ask, well, this is not the exact words I memorized. You get the point? Because there's an explanation to that. Okay, spin quantum number. Okay, spin. You're going back to the azimuthal quantum number, the angular momentum quantum number. It was to do something that is the shape of the subshell. Okay, shape of the subshell or the sublevel, like that. You need to understand this, the shaping. You get the point. Okay, and that often you can say, oh, there's somewhere along the way they will be oriented in the XYZ axis. Like that. This is also the basis of animation in a cartoon show or in the movie that involve cartoon series. So, the atoms and electrons are being studied there. That's why it will be rotated in the X and YZ 3D. Okay, get the point? So, the basis is quantum number study. Okay, get the point? Or particle chemistry. You get the point? Things like that. X and Y and Z, the orientation of the particular, atoms, whatever. Okay, number 3, magnetic quantum number. It has to do something with the number of orbitals. Number of orbitals. Why I put the keywords? Because in our definition, we will use this. Okay, number of orbitals. Okay, number 4, it has to do something with that. Okay, the positioning or the orientation of your electron. Once it is positioned, then you will orient that somewhere along the way. East, west, north, south, up, down, side, like that. Oh, so it will be rotating. Things like that. You get the point? Or orientation. Okay, like that. Okay. This is also the same thing, safety orientation, because your mind will be oriented to different topics, and it looks like your brain will understand so many topics, and it will be keep rotating your understanding. That's why orientation is the term there. Okay, you got the point. Or it could be an induction, because you need to induce, meaning you need to produce information so that the students or the new workers can understand really what are the potential hazards and risks involved in the scope of works in the future that they will try to face in the actual scenario of the workplaces. Okay, get the point. So induction also, the root word there is induce, action verb. So it becomes induction because it's already a process. Orientation also is a process, but the root word is orient. You get the point? So both have action verbs, orient and induce. You get the point? Things like that. So 1, 2, 3, 4. What you will remember always, if it is a process, an operation, it ends with T-I-O-N. Shown, 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 shown. So orientation, induction. You get the point? Things like that. Okay, now we have here principal quantum numbers, azimuthal. Oh, we are very lucky. The azimuthal and angular have the same letter A in the first letter of a particular word, right? And then we have magnetic quantum number, letter M, spin. Now, there's a rule there here because we need to try to get the P, A, the N, the S as our acronym in our numerization. So we have now P. So this is my technique in phasing examinations, even in the past. Okay, P, A, N, S. In the Bush examination, there's a lot like this. And also in the auditor, OSHA's lead auditor examination. Okay, P, A, N, S. So PAMS. So take the word PAMS in your brain cells. Oh, PAMS, meaning principal quantum number, azimuthal quantum number, angular momentum number, like blah blah blah, so and so. And magnetic quantum number, then S will be the spin. So you don't need to add a quantum number every time because that's the root, the main idea. You will remember only the P, the A, the M, the S. So the moment you will answer in your test paper, you need to write that fully in a paragraph, especially if the question is an easy type question, because the point things like that, or the test really requires you to explain, to define, to outline things like that, because outlining we need to have descriptions, but listing and enumeration you don't have to. Again, so in a test called listing, enumeration and outlining would mean the same thing, but the only difference is that outlining, you need to give descriptions, okay, and examples as well. For example, outline the 4 quantum numbers. If I will answer only the principal quantum numbers, your points are very low. You need to say principal quantum numbers, example, principal quantum number, as if your scores will be B. Okay, but if I was change the, I will just say enumerate the 4 types of quantum numbers, or list the 4 quantum numbers. You don't have to give examples. You don't have to define each or talk a lot with a particular, listing. You get the point? Or anak siya ang difference sa outline. Outline, you have to outline really. You get the point? Things like, because there's a lot in the, especially for taking the Bush diploma, level 3, level 2, whatever, or IGC in your safety career, if you are ready to grow, things like in an OSH world as a safety professional, then you need to apply this technique. This is acronyming during study. Okay, and there's a lot. So for example, you will be dealing with, oh gosh, what are the fire hazards? And there's a lot. Let's say 12. Then you need to remember only the first letter in each sentence, and bingo, you can create your words because you understand really what it's all about. Okay, because that is your career path. It's very insurmountable that you cannot understand cumbersome all the topics there. You get the point. Okay, my words there are difficult and profound are insurmountable and cumbersome. Insurmountable meaning difficult. Okay, impossible. Okay, things like that. And then cumbersome meaning complicated. Adjective. Okay. I only change a little bit to make it different. Okay, so we have here the 4, right? Now, in the number 1, we said energy level. So you talk with energy level. Okay, principal quantum number describes the energy level of an electron in an atom. What do you understand by that? Energy level does do something with N1, N2, N3, N4, meaning the shell. Okay, that's energy level. I discussed that a while ago or previously, right? So it's represented with the word letter N. Okay, be careful with the letter N because in science it has several connotation. Okay, or ideas or meanings or whatever. So N, it is the number of moles in physical chemistry. Okay, but here in chemistry lecture 1, it's not. It's really energy level. You get the point, especially in the topic of quantum numbers. You get the point. Oh my gosh, what's happening? Lobat, the microphone is lobat or not? Okay, we go to number 2. Azimuthal quantum number or angular momentum quantum number. So it has to do something with the shape of the subshell and the sublevel. Okay, meaning it describes the shape of the sublevel and the subshell, okay, in your electrons of an atom. Okay, in that particular energy level also, of course. Okay, things like that. Okay, number 3, magnetic quantum number. It has to do something with the number of orbitals. Okay, so I will say also, determine or describe the number of orbitals available within the sublevel and subshell. So meaning, it will try you to determine how many, like that, orbitals are there in SPDF, like that, okay, subshells and sublevel, okay. Number 4, positioning and orientation. Okay, so spin quantum number describes the electron positioning and orientation when they occupy in each orbital, things in the energy level, things like this. So in here, we completely understand what's the definitions. Now we go now to illustrate some, drawings or whatever, so that we can really understand. Because the points I need to erase this. Okay, you write this already in the blank sheet of papers or not. It's up to you. Okay, you get the point. Now, go back here. And now let's discuss one by one. Principal quantum number. Okay. You get the point. Our objective here is to learn what is a quantum number, its types, and the electrons, subshells, magnetic spin, azimuth, blah, blah, blah. Okay? Things like that. You get the point. Ganon. Okay. Okay. Now, for example, if you buy a periodic table and then, let's say you are a first year high school or a college student, because all college students have chemistry, I think so. Even the accountancy, BS accountancy have also chemistry. I think so. Not really that sure, but in the curriculum of education, Philippine educational system, they really include chemistry in all the curriculum of college courses. Okay, more than the biology, because engineering students don't have biology. Okay, but all engineering students have chemistry. You get the point? Imagine how chemistry is important. Biology also is important, but what I'm trying to emphasize, they put more chemistry in all courses rather than the biology. Because it cannot be denied, you will use chemistry somewhere along the way, being an engineer in the future, being an accountant in the future. For example, if you take your coffee and you stir the powder, you may observe, oh, it's really dissolved in the water. Things like you will never explain or you will never talk a lot with your colleagues. It's in your brain cells only. Yeah, describing because you have the eyes, right? If you have the eyes, you have your observation. Okay, in your eyes. But sometimes it doesn't mean that you have your eyes, you have to talk every time what you see. Right? Sometimes you keep that in your mind and you'll never share that with anybody. Because if you talk that, sometimes they will laugh at you because you are highly scientific in nature, and sometimes they cannot understand your behavior about that because they are not really engineers. For example, only. Okay, like also in the context of accountancy, the people also are talking about the cash flows, like I am there also. It looks like also that I'm also not interested. Okay, because that's all about money matters and it's not my profession. Though I really want to learn for me to add knowledge. It's okay, but the way I listen, it looks like awkward because that is not really a part of my profession. The same thing also for the science professionals. They are not really interested. Okay, the banking and finance, if we will talk about, oh, this a colloidal suspension, what will happen if there will be a Brownian movement due to this colloidal suspension in the presence of, Tyndall effect in chemistry? So they will be shocked, of course. What's that all about? What is trying to say? I cannot understand. But if your colleague is also a chemical engineer or a chemist or a science professional, they opted to understand what it means. Sometimes they will talk and the conversation flows smoothly. Sometimes, right? So that's what it means. That's why chemistry is really provided in all courses all over the world in their curriculum. Okay, for whatever courses. But not all courses putting or provided biology of all courses unless you are taking medical courses. You have biology. Okay, I don't ask anybody about this, but this is through research, reading like that. But if that I tried to ask really, maybe it is not true. It is not true. It is true. It depends. What I'm sharing is the context or the ideas of what I really read. I research. You get the point? Things like that. Oh, anak siya. Okay. So, it looks like they will not be interested anymore. They will opt to say, nakalimot naman ko, anak. Things like that. You get the point? Uy, so naman na, things like that. Okay. And this is common. It's really common, or the human nature to say like this. Okay, get the point? Okay. Going back here. Okay, now we start with the principal quantum number. My point there in my discussion is simple and straightforward. They put chemistry in all courses, but they'll never put biology in all courses. Get the point? Okay. Now we have principal quantum number. Okay. Nakakaloka, no? Principal quantum number. Okay. Ganon. So energy levels, it's gonna be small s, it's gonna be N1, N2, N3, N4, like that. So if we try to do the one single atom class like this, okay. Big circle, right? Now, so this is an atom, and the nucleus is in the center. Okay, nucleus. Nucleus consists of protons and neutrons in the center, bonded together because of their similarly values of the mass. Okay. Their masses is going to be 1.67 times 10 to the 27 kilograms. Okay, this is the N1. And you have also the energy level 2. Energy level 3. Now take note for the words utilization in English. Very important to understand. Okay, when we mean of principal quantum number, we mean of energy level. N, as I told you a while ago. When we speak also of energy level, that means shell. Okay, shell. Or level. Okay, like that. That's why we say energy level, because what's there occupying are electrons with energy, with each other. So electron 1 has its own energy. Electron 2 has its own energy. Since we are referring to the energy, so it becomes energy level. We describe it adjective. Okay, so what's in the leveling is the energy of all electrons. Sometimes we need to drop that because we are telling you another term. Okay, get the point, things like that. So shell also, shell. The shell also is this. Okay, like that. So meaning the level. Okay, but both of them all are energy levels. Okay. I say this because during examination in the future, you can understand. Okay, because sometimes also it will be roughly confusing. Things that would ask, what is the level of calcium? Like that, and you be opted, what's that level? Like that, and you don't understand that it's just the same meaning in energy level. You get the point? And the word energy is dropped off during the question. Because it looks like so general, the kind of questioning, and then you did not answer exactly the same as what you understand before, that it is energy level. You get the point? And sometimes also, how many shells are there in potassium? What's that all about? How many shells are there in potassium? You will equate that to another context. You will say shells like in the sea, right? There's a seashells there. You got the shells, the shells craft like that. And then because you know the kind of questioning is too general. You got the point, but why potassium is attached there in that particular question? So it's gonna be chemistry, right? Like that. So it's gonna be the level or the energy levels. So you need to answer exactly the period number where this potassium and calcium located, because the period number, the horizontal rows of a periodic table, that would mean the number of shells, the number of levels, the number of energy levels, things like that. Now, if you are trying to listen for other also people are talking about the outermost shell, because it's always spoken of by anybody else because it's popular, right? So the outermost shell is the last shell of your atom. This one. Adjective again. Outermost. Meaning description, adjective. Outermost shell. Or shall we say that in another way around also as outer layer. Things like that. You get the point? Or external shell. If we try to look at this atom, the only external is this, the last. You get the positive. We can see also external shell, outermost shell, outer layer shell. So it depends how you really phrased your adjectives, as long as you understand what it means. You get the point? It's very clear. Right. For example, if I have here, what is the energy level of what is the energy level of chlorine? I try to practice you in this way because this will come out in the board examination. Things like that. What is the energy level of chlorine? Like that. So let's assume that there's no choices. Yeah, like that. And you cannot memorize. Oh, it's very difficult to write. Things like that. This is where stock knowledge and acquired knowledge holds through. You can pick there in the hippocampus part of your brain cells, which is considerably a pool, P-O-O-L, a pool of knowledge inside your hippocampus part of your brain cells located in your cerebrum vortex in our central nervous system. Right? It's in there. And you have to collect it back because you are asked now. You get the point, things like that. Because you don't have choices anymore. There's no multiple choice. How can butikaw, ikaw? So I cannot answer. There's no cell phone. There's no Google search anymore. There's no books because it's not allowed to use books in the examination. Things like that. And it's not allowed also to bring periodic table either inside the examination. So the only way to survive is that knowledge and acquired knowledge. Okay, so I can say, three, energy level 3. For example, only for the purpose of discussion. Okay, you got the point? So meaning hypothetical, as long as we understand really what I mean. Okay, you got the point? Because I don't also the periodic table in my hand. You get the point? Okay, right? So ganon. So, for example, I will say, hydrogen. What is the energy level of hydrogen? Okay, without periodic table, it's very easy because it's topmost. It's very special. So if you try to, let's try an analogy between a class, in a class, for example, class A, class B, like, a school with different, teachers, or let's say, teacher A, teacher B, we have 30 students each room, like that. And then during the commencement exercise or culmination program, there will be honor students, right? First honor, second honor, rank number 1, number 2. Always first honor is the hydrogen. So if we try to, hydrogen is really the summa cum laude of all the periodic table. Okay. Summa cum laude, first honor, high rank. If you try to have an analogy, in academic accomplishment or achieving good scholastic records, things like that. You get the point? Okay. Because hydrogen is very special at the top. So we need to say, if I will say, how many energy level of energy, you will answer 1. Because he is on the top. Again, he is on the top in the period number 1 at the same time in the group number 1. Okay? So of all the elements, very special. That's why, because of this summa cum laude hydrogen, we will not survive without hydrogen. We will die automatically without question at an instant. Okay, why? Because hydrogen is in water. We drink water. If you don't drink water, then we will die. Our body composed of 75% water, not the substances. Just like the planet Earth, 75% body of water also, rather than the land. It comprises more than the solid land. The same also inside our body. What comprises more are the fluids, the liquids, and most of them are coming from water. And water composed of 2 atoms of hydrogen. That's so special. That's why hydrogen is in the top of the periodic table. Any questions so far? Nothing, right? Maybe also in the examination in the future we say, which is the most special of all elements in the periodic table? Because advice already the questioning. And you cannot answer anymore. Because you don't remember the relevance and existence of a hydrogen element. Not only that, hydrogen is present in the Proxima Centauri. What do you mean by Proxima Centauri? Proxima Centauri is the scientific name of the sun. Because sometimes also in the examination, they will not say exactly what really the word sun. Sometimes they will say also, which is called as a Proxima Centauri. And you don't know that that is the scientific name of a sun, S-U-N. Okay, so the same as saying, the Proxima Centauri composed a lot of hydrogens. Because, as I said a while ago, hydrogen is a summa cum laude in the periodic table. It's in the top because it's very light among of all the elements, very flexible, things like that, with atomic weight or atomic mass of 1.008 with a charge of positive 1. And discovered by Mr. Henry Cavendish. And the proton in it was discovered by the model of Ernest Rutherford. You get the point, things like that. And you should remember this carefully, okay, if you love science. Things like that. So these things are already memorized in high school pa lang siya, and it's coming back until now. Okay? That's the knowledge, as I told you earlier. Stack knowledge or acquired knowledge. It will never be Google searched. Okay? Things like that. So we have now the principal quantum number. Okay? If you will say also, for example, okay, I will say, wait, if I will say thorium, thorium. So what's this all about? What's the thorium? Thorium is a radioactive material in the last row of our periodic table, which is an actinide series with atomic number or atomic weight of 232. Thorium, right? 232, and uranium is 138. Just review this also because I'm not really specific. Maybe it's wrong because that is 30 years ago. Okay, you get the point? Okay, let's say thorium example. So thorium is in the last, right? So you can say 7, 8, 9. You will say 9 energy level. Because the last level is 7. Because this actinide series and lanthanides are separated in the bottom. This is the purpose only for this to compact because it cannot accommodate it there in the original periodic table. Okay? So you will say, there are 9 energy levels, sir, in the thorium. How about uranium? The same. Sir, there are 9 energy levels in the uranium. Things like that. Okay? It's very clear. Okay, for example, let's go simpler. For example, if I have helium, neon lang. Okay. How many shells are there in neon? Or how many levels are there in neon? Okay, there are 2 only, sir. Okay, so if you draw an atom, there will be only 2 like this for the neon. Neon has an atomic weight of, I think, 10, 10 something, 10 point something grams per atom. Things like that. I'm not really sure also, forgive me, Okay, for the exactness. Well, exactness or preciseness of the answer for this particular atomic masses and atomic weights. Okay, it's gonna be like that. And now we go to the second one, which is the azimuthal quantum number, or the orbital angular momentum quantum number, CHARIS. Okay, you get that point. Now, the definition states describe the shape of the sublevels or subshells in an energy level. Okay, you get the point. Take note every word that I spoke. Okay, things like that, right? Okay, things like that. Okay, let's do this. Okay, azimuthal quantum number, so it's gonna be like here, okay? Our formula of azimuthal quantum number will be L, small letter L. Okay, so if you see small letter L in chemistry, I think there's no other except for love. Well, love is the this first letter is L. That's why it's purpose of humor only. Okay, so L. The formula of L is N minus 1. Meaning energy level, shell level minus 1. Or we can say also orbit minus 1. By the way, orbit also is a shell level, just like the planet Earth. The planet Earth revolves in a specific orbit along with other planets in the solar system. So the atom also have like that, the orbit, and that is the shell or the level, things like that. So n minus 1, this is your formula of your, okay, let's use the same terminology, so it will not be confusing. Let's just use angular momentum quantum number, Let's try to forget a little bit azimuthal. Okay, let's get like that. Okay, like that. So describes, okay, the shape of, okay, shape of my heart. Wow. Shape of the stars. O, diba? Ganon. Okay, ganon. Okay, shape of sublevels or subshells. Sublevels or subshells. Okay, why subshells and sublevels? Because this is under the level. This is under the shell. If we try to do that, that is the sub of the main level. Okay, that's the component. Just like a division, subdivision. Okay, like a component, subcomponent. If you are living in a division, okay, one division as a town, there's another separation for that. One of it are subdivision. That's why there's a subdivision place with a very beautiful houses. Okay, it's not division because the division is the owner of the whole place, which is the town, the barangay, the province. But you are only a part of it. That's why subdivision. The same also here in the analogy, sub-level, because this azimuthal is part only with the whole level of the energy level. The point and we determine the shape. Now, we have sub-levels now, S, P, D, F. So, Sotero, Patricio, Delilah, and Florencia. Okay. For the purpose of this humor only. Okay. S. Because S, Sotero. It's easy for me to remember. Okay. S. So this is now the S sublevel and S subshell. P. P sublevel or P subshell. D. D sublevel or D subshell. F. F sublevel or F subshell. So if I will say orbital, this is not the S orbital. Okay, because an orbital is the main component, it's not the sub. But this is PDF are sub. So maybe you will confuse. I will say P orbitals, D orbitals, F orbitals. It's not like that. That is the main commuting. You will say P sublevels, C subshells, like that. Okay, this one like this. Okay, get the point. You get the point now. Okay, the orbit is a shell. See, orbit is a shell, a level. So since this is subshell, and the meaning of orbit is shell. So you will never say S orbital. You will say S sub orbit, S sub shell, S sub level. Okay, but never mind. Some of the teachers will say directly S orbital. That's not the same. Sorry. Okay, get the point. So that is S subshell, sublevel, and suborbital. You get the point. You get the point. Things like that. Now, so S, P, D, F. Okay, you get the point. Now the S shape will be like this. If this is our y-axis in math, we always have the x-axis. Sorry, x here, and the y-axis. Okay. Based on the study of these atomic orbitals or quantum, so the shape of the S subshells are like this, spherical. Okay, sphere. Okay, so if you can remember the square area of a sphere, 4 pi r cube, right? If you can still remember, or the volume in our algebra. But that is not our topic, but I'm just telling some of it. Okay, you get the point? So 1/3 pi r cubed, like whatever. Sorry. The area of sphere is 4 pi r squared. So the volume is 1/3 pi r cubed. Okay. I couldn't still remember exactly, but there's a specific formula or formulas of or formulae of sphere. So this is the shape of our S sublevel. Okay, ganon. Now, what is the shape of our P sublevel? So our P will be like that. Okay, just like this. Two lobes, like this. Okay. And it will be moving like that, and this is the Y here. So this is our P. Okay, like that. You get the point? Okay, our D, okay, and the F, things like that. Okay, ganon. Our D, so it's gonna be like, okay, our D will be like that. So, ganon. Turn, like that. Okay. Okay. Now our F is very complicated. Okay, our F is very complicated. It keeps on rotating. That we cannot determine exactly the shape, but it's gonna be like this, like this. There's so many F. You got the point. So the general for the F will be like this. Okay, and then like this here. Okay, like that. Sometimes you cannot explain this very comprehensively because we can see this in the microscope only, like that. This is only a rough overview what it looks like there. Okay, like that. This is the F or sublevels. Okay, things like that. Because our azimuthal or angular momentum quantum number is based on the shape of the sublevel. Okay. Things like that. And then, if I have an energy level of 4, for example, I say hydrogen with hydrogen, lithium, sodium, potassium. Let's say group 8 alkali metals. Okay. Metals that usually produce an alkaline solution in aqueous solution if we react this with water. Okay, so we have alkaline solution. Comes from alkali metals. Okay, group 1A. And it happens that potassium is in the number 4 of the row. So potassium has 4 energy levels. N is equals to 4. Potassium has 4 orbitals or orbits. 4 orbits lang. Okay, because orbital is another thing. Okay, so 4 shells, 4 levels. Okay, you get the point? Ganun siya. Okay, how many electron shells in the potassium? Your answer will be 4 because it's based on the energy level. You get the point? Ganun na. What is the azimuthal quantum number of the say potassium. So you use this formula. L is equals to N minus 1. So L is equals to N, level 4 minus 1. L is equals to 3. It looks like very elementary math, right? So we have now 3 as our L, or our azimuthal quantum number, or our angular momentum quantum number of this potassium. For example, let's face a board examination, for example, only. Question number 2, okay? Theory, like that. How many azimuthal quantum number in uranium? A, 4, B, 2, C, 3, D, E. Okay, this type of questions are not really discussed very well in our classroom instruction because we are not focusing in this kind of questioning. You get the point? So you need to remember the period number because it's a period number of the periodic table that is the number that consists or contains the number of electron shells and energy level, automatic. Okay? So you can answer directly. And it's easy to memorize because there are only 9 rows. Meaning to say, all elements will never go beyond 9. So that is your first identification. So all elements will never go beyond 9 orbits or 9 shells or 9 energy level. It should be, it's very easy to answer. Things like that only because imagine only 9. So it's not difficult to memorize, right? You get the point. The only difficulty to memorize is where it is exactly located in that particular level or shell. Okay, because it's not allowed to bring the periodic table in the examination. You get the point? Things like that. Now, let's go to the number 3, the magnetic channel. Okay, you get the point? The magnetic. Okay. But before going to the magnetic, we need to introduce theory statement. Okay, theory. Okay, because we often heard the word orbit. Okay, orbital, right? Things like that. An orbit. So definition, remember this because it's very common in the theory. Orbit. An orbit is a region of space. Okay. Especially in the quizzes. For example, if you represent your school in a chemistry quiz or science quiz board, so you should remember this type of questionings. The point, things like that. A region of space or probability. Okay, like that. Okay, that can hold the electrons. Okay, that can or that will. So English matters, right? That will hold the electrons. Okay. A region of space and probability that will hold the electrons. So in each orbit, there's a lot of electrons, as I told you. So it can only accommodate not beyond 14. 14 electrons. Remember this, the maximum number of electrons that our shells can hold are 14. 14 electrons. But sometimes it will be also asked, how many maximum electrons that our orbital can hold? Things like that. Okay? So I will explain this later why 14. Okay, things like that. Okay, that's the orbit definition, Okay, now, math postulate. Okay. In every electrons in an orbital, as I said, orbital has its own electron that occupy or hold. So we will say number of electrons, okay, then per orbital. Because these electrons are existing or occupying in an orbital, so it's like per orbital. This one, like number of electrons over orbital. So this means number of electrons occupying each orbital. Okay? You get that one. So this is our formula now. So in this alone formula theory, you can compute how many number of electrons because you have done the basis of calculation. If the question is, example, hypothetical. So it can also be happening that there's a hypothetical question because the main purpose of the examination is really to test if you really understand. Okay? It doesn't mean it's subject to reality or not as long as you understand. Okay, so there are times that it could be hypothetical in nature. For example, I will say, there are, hypothetical question, there are 8 orbitals in instanium. Instanium is a radioactive element discovered in 1952 by Albert Einstein. You get the point, and this has an atomic number of 251 grams per atom. So let's say instanium, there are 9 orbitals in instanium. What are the maximum of electrons that this instanium element can occupy? So you are asked by the electrons, and there's no data at all, even the numbers. So how can you answer that? This can be answered by theory. Okay, like this. So we have now the number of electrons per orbital, and there's 9. So you multiply that by 9, 9 orbitals. Right? Cancel the orbital. What will be left is electrons. So it's gonna be like that. You get the point? So, i-times na yun na mo siya. 9. Na maglibog ka, what is the electron sotero? There's no number of electrons. So this is another theory that the shell can occupy only of 2 electrons or an orbit. Okay? 2 electrons. Okay, you got the point. So why you say that? Because in an S sublevel, it can only occupy 2 electrons. So that is 2 electrons. Okay. You get the point? You get the point, mga palangga kong hitad? And this is also discussed in the theory of Pauli explosion principle. Things like that. You got that always contain the orbit always contains 2 electrons in an element, and that can have precisely more than 4 sets of quantum number. What do you mean by that? It looks like complicated, right? Okay, so you break that out, every words. Okay, 4 set of quantum numbers. That could mean the SPDF, 4, right? So, in every level, it's impossible you can have that 4. Okay? It's not perfect all the time. There's an S or sub-level, P sub-level, D sub-level, F sub-level, things like that. What it means, the Pauli exclusion principle. Okay, and each, okay, composed only of 2 electrons. So that's why 2 electrons per orbital. Ganon. So if I will ask, how many electrons that a uranium can occupy? Like that. You get the point? So, times the orbital. So, if we say we have 8 orbitals, or cancel na yun siya, then you have the electrons. Answer. So, remember this, only 2 electrons per orbital. Okay, get the point? Ganon. Okay? Makuha din mo siya ang imong electrons. Okay. You get the point? So, makompute din mong electrons. How many electrons are there in lithium? So, you can compute directly. Right? Lithium in your battery of your cell phones, and you need to establish how many electrons there. Okay? And somebody will ask, how many electrons in your lithium battery? Exactly. That's the point. So, it looks like a strange question, but it tests you really the concepts of chemistry. Things later. Get the point? Ganon. So, lithium, what's that? Helium. Okay, it's in number 2. Okay, so this is 2 electrons per orbital. Okay, and the times 2, so they're gonna be 4 electrons. Things like that in the lithium. 4 electrons in the lithium. Okay, now it's closely related to the atomic weight. Okay, things like that. Okay. So that is our theory about it. Let's go now to the azimuthal. That's L. Now we go now to the magnetic. Number 3 na kano? Magnetic. Quantum number is ML. Okay, ML. So ML, or magnetic quantum number, describes the number of orbitals in each sublevel. For example, how many orbitals in S? See? That's why I told you that the orbital is not the same with the sublevel. Okay, determines the number of orbitals in each sublevel. So understood, they are not the same thing. Again, phrasing it again. Okay, magnetic quantum number describes and determines the number of orbitals in each sub-level or subshell. Meaning to say, in that alone, they are not the same. You will never say S orbital, but you will say S sublevel or S subshell. In S sublevel, there are a lot of orbitals there. Because other teachers are teaching in another way around. They will say S orbital, P orbital. It's not orbital. It's sublevel and subshell. Each subshell and sublevel composed of orbitals in there. So you mean to say that is not the main caption, that is the main heading or the main idea. It's only the specific out of that. You get the point? So the way how we teach sometimes, it looks like gray, G-R-E-Y, meaning gray, meaning a lot of confusion will steered in our mind. Things like that. So we will just pray that our mentors all over the world will teach explicitly during their elucidation of their topics, things like that, or whatever. Okay, you get the point? Things like that. So, S. O, ganon siya, no? So, S, subshell. Kung nabot ang subshell o sublevel, para kita maglalis. Okay, sublevel. Okay, like that. Okay, you get the point? Ganon. How many orbitals are there in S? Okay, now, in this, you need to remember the off-bow principle. Okay, off-bow principle. What's this all about? Okay, determining the number of electrons, you will remember Mr. Pauli exclusion principle. There are only two electrons. Two electrons lang talaga siya over the orbital. In that way, if the orbital are given, you can compute the number of electrons that the subshell can occupy. Okay, but off-bow principle is another thing. Okay, you got the point of the off-bow principle. Okay, in the off-bow principle, you need to fill the electrons in the subshell and sublevel starting from a low, okay, atomic orbital energy or low energy atomic orbital, low energy to high energy atomic orbital. What do you mean by that? For example, if I have 4 shells, they will start first in the inner shell. And then later on, that electron will jump to the second layer or shell, and later on, the electron will jump in the third. They cannot do directly jumping to the highest because they don't have enough energy yet to do that. Just like also the person, if you try to learn, you will learn immediately the maximum. No, it's not. You will start also with the minimum. If you try to have an analogy, the same also with the off-bow principle in terms of electrons. Human beings also like that. We don't go directly to the maximum learning and maximum knowledge. It's a gradual process, even though you are summa cum laude. You get the point? This is the real thing in life. We need to learn gradually. Okay? And you can learn gradually, and the most of it are through experience, because experience is the best teacher. You get the point? Things like that. Okay? Things that off-bow principle is the same story, right? Electrons feeling start with a low energy atomic orbital to the highest energy atomic orbital. Things like that. I will try to draw that one so that it's a clear picture. Okay, the electrons here in the first shell, before jumping on the second shell, okay, it must be filling first 2 electrons here. Okay, then go back there and filling also enough 2 electrons and other, because in the first shell only there are 2 electrons, in the second shell it's more and then more. The bases are 2 electrons always. The first level is the basis. Okay, basis of calculation is the first shell. That's why 2 electrons per orbital. Okay, because it's fixed there. In the second layer, changing. In third layer, changing. Things like that. Okay, in the off-bow principle. So if you jump here, jump here, jump here. So what do you call that energy? That is a excited state or ground state of an electrons. Okay, because at that time they have enough energy. Okay, excited state and ground state. That's the term for this. The off-bow principle. I will erase the off-bow principle, no? Things like that. You get the point? Ganon. So, muna siya may tabo karon. Now, ang atong ML karon charis. Okay. So, for example, guys, okay, na ako'y energy level. N1, N2, N3, N4. So, this is your, let's draw a table. Okay, like that, a table. So, we can understand really what's going on here. Right? Okay. Okay. So, like that. A table composed of rows and columns. Right? Like that. Okay. Now this is our principal quantum number, PQN, or the energy level, N. In the second column will be our azimuthal L, which is N minus 1, right? Like that, this is azimuthal or the angular momentum quantum number. So let's have to put this on L para madali. L here and here. Okay. Now N minus 1. So, if n minus 1, so we need to say 1 minus 1 is equal to 0. So, our L here is 0. Okay, for azimuthal. Okay. And energy level 2, our L is n minus 1. So, 2 minus 1 is 1. Because I told you a while ago, the formula of L is n minus 1. Okay. In 3, we have n minus 1. 3 minus 1, 2. Like that. Our M4 is n minus 1. Okay, that is 3. Okay. Now in this alone, so many questions will happen. For example, I will say, how many azimuth quantum number in the third energy level? So your answer will be 2 by looking at the table. Or I will say, how many azimuthal quantum number in the first energy level of an atom? Whatever element is that? Your answer will be 0. Okay, so now we go to the ML. Now go back to our present topic, ML. Okay, like talagang charos. Okay, now. Okay, now. L is equals to 0. Our ML also will be equal to 0 because it's not moving. Okay, get the point? Things like that. 0. Okay. How about our ML in 1? So it's gonna be 1. If you remember the mathematics, guys, no? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So this will be used here. That's why you cannot take chemistry if you will not pass algebra. Wait. No, it's not. It's taken simultaneously, chemistry and algebra. But what I mean, you cannot understand properly also if you don't understand algebra, math, basic math, arithmetic. Okay, because quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, 0 here, right? In the center, we have 1 here. Things like that. Okay. So, let's say this is 1, 0. Or 0, 1. Let's start with the less value. 0, 1. Okay. Take note that 0 is not a number. Special treatment, just like a hydrogen in the periodic table. That is not a number. The number is not 1. Okay. But it is a digit or digit. But it's not a number. You get the point? Because digit here specifying how many. To count 1, 2. If you say I have 1004, how many digits? So 1, 2, 3, 4. Okay? But the 0 there are not numbers, only the 1 and 4. In basic math, right? Algebra or arithmetic or whatever. Okay, things like that. Now, in your azimuthal 2, so you say 2, 0, 1, 2, right? Things like that. Okay, take note this carefully. And 3, so 3 will be 0, 1, 2, 3. Like that. Okay, that would mean like that in your ML. You get the point? So, since in ML, you need to determine how many orbitals are in there. So orbitals, remember that an orbital, okay, in each sub-level would not mean only positive because they will go in the another way around, the opposite direction. And these are all positive, right? 0, 1, 0, 1, 2, 0, 1, 2, 3. You got the point? Now, there's a negative part because if they rotate, it's impossible. There's no opposite sign. Things like you got the points. They will also travel in another direction, blah, 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 so and so. That's how the behavior of electrons. So you need also to consider that negative 1 and negative 2. Okay, in the 0, it doesn't matter. Okay, here, negative 1. If we have positive 1, we have negative 1. If we have positive 1, we have negative 1. If we have positive 2, we have negative 2. For the reason that they have opposite positioning somewhere along the way when they travel in each shell or orbit or energy level. That's the explanation by common sense. Okay, now we have 1, 2, 3. So 1 here, negative 1. 2, negative 2. 3, negative 3. Now, this is your ML. You get the point? Ganon. So, if we try to determine the number of orbitals in sublevel, then we have another sublevel, another column. Okay, sublevel, okay, number of orbitals. This is the philosophy why our teachers always say S orbital, P orbital, D orbital. Okay, but this is P, D, and orbital. This is not really the orbital. That would mean the orbitals, how many orbitals in each sublevel S, P, D, F. The S is not an orbital. Okay, that is only the title because there are a lot of orbitals there. S slash orbitals, but that would not mean orbitals because that's confusing during examination. You will say, what is an orbital of this particular blah blah blah? You will answer S. No, that's subshell because you always look at the table when your teachers are drawing the table. There's always S dash orbital, P dash orbital, F dash orbital. This is confusing to the students. You get the point. Sorry, they will also answer S, P, D, F orbital because the word you put on the table are having orbitals words. You get the point? So be careful also. How many number of orbitals in S? How many number of orbitals in P? That's what it means. Not directly that it means orbital, the S, P, D, and F. Okay? Ganon. Okay. So I will put in this way. Sub-level number of orbitals, much better. You get the point? Rather than saying the S, the P, D, F. So I will say now, S. Take note in my discussion, I don't put the word orbital because this is confusing. I will just put S. How many orbitals in S? Okay, I don't put the word orbital because it will create confusion. You get the point? Because you mean in that S is also an orbital? No, it's not. It's meaning the number of orbitals in the S sublevel and subshell. You get the point? Ganon. Now we go to the S. Okay, so how many orbitals are in there? Now you need to count. Okay, because in the sublevel or in the ML, it says the number of orbitals in each sublevel. So count to 1. Okay, then the P subshell. So 1, 2, 3. 3. D. 1, 2, 3, 4, 5. F. 1, 2, 3, 4, 5, 6, 7. Okay, now, if you study only memorize plainly, you can never understand this. It will lost in your mind after 2 months, 3 months, 4 months. You only remember saying 1 S, P, 3. It's not like that. You should understand where this 3 comes from. You should understand where this 7 comes from, where it is driven by. Things like that. So that you can really understand the whole framework of what you are studying. You get the point? Things like that. And we must be proficient in that way of memorization. Ganon? Yes, very strict, right? Ganon talaga ang life. Very strict in studying so that we can also learn in a manner of explicit learning. Okay, now 1, 2, 3. If the question was saying, how many orbitals in D sublevel? So the answer would be 5. Diba? How many orbitals are there in S sublevel or subshell? 1. Ganon. So if you say, how many orbits in S? Orbit and orbital is no longer the same. Okay, how many orbits in P sublevel? La. So you will base on the N. There are 2 orbits, but 3 orbitals. Be careful. Okay? There are 2 energy levels, 2 shells, 2 principal quantum number, okay? 2 orbits, but 3 orbitals. Meaning, orbit and orbital in this context of study is not the same. You get the point? Careful in your memorization technique, the way how you comprehend. Okay? In math, again, this is the sign of inequality. You get the point? Or inequity or disparity. Meaning adjectives, the same meaning. So if you see a symbol like this in the books, in the Google search, in the website, like this, see? Like a shark, like that, no? So that would mean in, not equal, not the same, things like that. So meaning to say, orbit is not the same with orbital because orbitals are present in one orbit and there's a lot of orbitals. It could not mean only one. Because if there's also one orbital and one orbit, so that's equal. We can say orbit and orbital have the same meaning, but actually it's not. Why? You get the point? So the figure would matter also in the English language, the way how you understand. Okay? Because say, how many orbits in a first energy sublevel? So there's 1, like that. Okay? So how many your orbital? Things like that. Okay? So you look at the table. Okay? You can answer now. Now the last part will be the spin quantum number. Okay. In the spin quantum number, chararat, okay, got the point? Okay. You need to remember the Hans rule. Okay, so you need to extract in your brains. No, there's rules. So what I discussed a while ago, of bow principle, like that. You get the point? Ganon. Then Pauli exclusion principle. And now Hans rule. The Hans rule will be applicable in the last part, which is the electron spin quantum number, the positioning. Okay, whether it is up and down, blah blah blah, so and so. Okay, so it does matter. Just like a human being, also we take actions every day. So we need forward, backward, sideward, another word. So you get the point, or circular. Okay, we are not stagnant. Okay, we are not stationary. We are moving. You get the point? We are only stationary when we are sleeping. So, when we are sleeping, we don't have quantum numbers. But if we are alive and walking it, we have quantum numbers. As I told you, all the food we have atoms and electrons. You get the point? So that's why we have quantum numbers inside our body. You get the point? Ganon. Because of the food we eat and the substances we eat. Basically, these are made of atoms. You get the point? Things like that. Okay. Now, going to our last table will be the MS na ni siya. Why MS also? Because M means magnetic. The first letter of magnetic, M. Okay. S meaning spin. The one ago is ML, magnetic, then L is azimuthal. So everything will be driven by the correct and preciseness of declaration of the variable. These are variable because these are letters. Okay, subscripts are numerical. 1, 2, 3. Superscripts are numerical. That's exponents. Exponents are superscripts. Subscripts are really part of computation of the atoms. Subscripts in chemical formula are hypothetical. It can only be used to declare an atom. You get the point? For example, H2O. So what is this 2 all about? Okay, you can never say that is mole. You can never also that is atoms. Okay, directly. Okay, so this is hypothetical first. Okay, not really with relevance. If you multiply that with the number of moles beside hydrogen, then that will be with relevance already. So you say 2 times 1. Okay, 2 times 1 mole equals to 2 atoms. This is also strange, right? Very strange. Because why atoms? Because there are 1 mole only of this hydrogen. Okay, so 2 atoms. So oxygen. There's no subscript. So 1 times 1 mole is equals to, okay, 1 atom. So you see, total 3 atoms. Imagine, the mole, 1 mole of water molecule and 1 molecule of water. See? By H2 alone, we have 3 atoms. Okay, brought by the hydrogen and oxygen. But we have 1 mole of water or 1 molecule of water. So, how many H2? So, you can never say directly na Avogadro number, which is 6.023 times 10 to the 24 per mole. So, very great, very big difference when to say how many atoms, when to say how many moles, when to say how many molecules. If we say, or if we ask how many molecules and how many moles, we need to remember Avogadro number. But if I would just ask simply how many atoms, you don't have to use Avogadro number. Just like the water. So many times you cannot answer directly. If I would say, how many moles of hydrogen gas? Okay? How many moles of oxygen gas? You can never say directly, you can use the Avogadro number. But if I will say the totality, how many moles of water? You can say directly, 1 mole of water, 1 molecule of water. In this context, the molecule and the mole will be the same. Okay? You get that? Why? Because there's nothing beside hydrogen. All are 1. But if there's 3, 4, 5, blah, 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 so and so, then it will matter now how you to use the molecules and the moles. You get the point? So sometimes you will confuse what are moles, molecules. Others also will say the abbreviation of molecules. Okay? You get the point? But actually, it's not the same. Okay? Because when you say molecules, it has to do something with the molecular covalent bonding, things like that. It has to do something with ions. But moles are not expressed in ions. You get the point? So ionization. If you can still remember the study of, electrolytes. Okay, but we are not studying electrolytes here. Okay. I think we will be dealing that also later on. Okay, so things like that. So our spin, that's the last column of the table. I erased already. This is gonna be like that. No. So this is gonna be positive 1/2 and negative 1/2. Why 1/2? Because there is a total of 1. Okay? 1. And then the positive of F and the negative of F. So 1/2, 1/2 of each orbital. That's why positive 1/2 and negative 1/2. Okay. So the positive 1/2 will go up. The negative 1/2 will go down. Okay. So obviously, the same story with the topics of motion, velocity, speed, projectile in physics. Example, Junjun throw the ball, blah blah blah. What is the acceleration, blah blah blah. So the directioning is the same also, constant. Okay? Up, positive, down, negative. This is standards all over the world. Right? So we will say that the going up is negative. So it looks like you are crazy anymore. Okay? So this is a matter of generalities or typical, the same. Okay, all over the world. The concept of this going down positive, going down negative, and going up positive, it will never change. You get the point? Things like that. Just like also turning to the left, negative, turning to the right, positive. Okay, and that is the spin quantum number. The positioning, orientation, direction, things like that. You get the point, ganon, of your electrons in your particular orbit. Okay, or shell, or energy level, ganon siya. Okay, now, if you ask a question that goes like this, okay, Okay, if I have a question that goes like this. What is the orientation or the positioning of the seven orbitals in the F sublevel? F sublevel. So F sublevel F. In the F there are seven as far as we could remember, right? I mean, this is only where it comes from. It's not an issue already. Right? Look at points. So seven orbitals. Okay. Ato na yung gisagad sa seven orbitals jugta. Okay, like that. Okay. So the question is, what is the orientation? Okay. So the orientation spin will be basing on the last electron occupying the last orbital. Okay, so orbitals is 1, 2, okay, 7 na to. 3, 4, 5, 6, 7. So these are the orbital. Orbital 1, orbital 2, orbital 3, orbital 4, orbital 5, orbital 6, orbital 7. There are 7 orbitals in the F sublevel and F subshell. Now, remember the Pauli exclusion principle. It's in here that we can apply all the principle. Pauli exclusion principle, that in every orbital there are only 2 electrons. Okay, 2 electrons that will occupy and cannot have precisely more than 4 sets of quantum number. Okay, so here, so you will say 7. Okay, for example, how many electrons in F? Okay, how can you say how many electrons in F? Okay, because we cannot go here because we need to put electrons. That's our problem. We cannot have our spin positive up, going down, negative, because we don't, in the first place, we don't know really yet how many electrons in the F sublevel. And so we know that in our F sublevel or subshell, we have 7 orbitals. This is right here. How many electrons in F? Okay, this is already also a stock knowledge or acquired knowledge in your chemistry. So I said a while ago the theory, right? That 2 electrons per orbital. And now we have already the orbital. So I told you 7. So times 7 orbital. 7 times 2. Cancel ang orbital. So there are 14 electrons. So these 14 electrons, we will try to fill this in each orbital here. But each orbital will have only 2 electrons as per Pauli exclusion principle. You will never put 3, you will never put 4, only 2. Because if you put 3, it will deviate from Pauli exclusion principle theory. You got the point? So we will put, okay, now, you will not put also directly the 2 electrons in each orbital because you deviate the Hans rule. Okay. So what is the Hans rule really all about? That if you fill the electrons in each orbital, it should be singly going from the first orbital to the 7th orbital. Before it will have 2 electrons in each orbital but having opposite spin. So meaning to say, in each orbital, opposite spin, 1 electron must go up and 1 electron must go down. And this is the Hans rule. Okay, you got the point. Mauna siya but pasabot guys sa Hans rule. You get the point, anak siya. Okay. So, 1, 2, 14 electrons, see? 2, 3, 4, 5, 6, 7. Okay. So, after up, going down. Because up na siya. See, 1, 2, 3, 4, 5, 6. So, 7, 8, 9, 10, 11, 12, 13, okay, 14. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, ganun siya. So, 14. Review, 14 electrons. Up first. 1, 2, 3, 4, 5, 6, 7. Down. 8, 9, 10, 11, 12, 13, 14. Okay. Now, what is your electron spin here in your F subshell? Ang question ako, what is our electron spin quantum number? Electron spin quantum number is the question. So you will answer only either positive 1/2 and negative 1/2. So since it's going down on the last orbital, so your answer of electron spin of your F subshell and sublevel is negative 1/2. That is your Ns. Now, what is your Nl? Magnetic quantum number. What is your magnetic quantum number for this? Okay? So we have 7. Take note. We have 7. 0, negative 1, negative 2, positive 1, positive 2, positive 3. Other side. Negative 1, negative 2, negative 3. Oh. Sa man imong kwan ana aron. Okay. Unsa man jud ang imong ML ani niya. Okay. So for your ML for this, you got the point. Unsa man na siya? 0, positive 1, positive 2, positive 3, or negative 3. Okay, now, you will try to make this equivalent in your orbitals. Orbital 0 will be the here, center. 0. Negative 1. So, positive 1, positive 2, positive 3. Negative 1, negative 2, negative 3. So, you will say, in your first orbital, there's negative 3 azimuthal. In your second orbital, there's negative 2 azimuthal. In your negative 1, negative 1 will be in your third orbital. So there's a corresponding, right? There's a corresponding like that, like that, like that, like that. So this will be your magnetic quantum number now. I put, because you have 7 orbitals, man. So put that each there, in each orbital. So 0, here, 1, there, 2, there. Put it precisely, so that you can have the correct answer. So since he's 3 here, okay, and it is the last where our electron landed on a negative spin, so our ML will be 3. Positive 3 or 3, it's okay. So if the question is so many letters, in your energy level 4, because F is in the energy level, okay? In your energy level 4, how many orbitals? How many orbitals? How many electrons? What is the magnetic spin quantum number? What is the electron spin quantum number? What is the azimuthal quantum number? In one question only, there are 5 questions to be asked, and you can answer it perfectly. You get the point? So if you will just understand, you get the point. So let's have another example, so that I can understand pag you know. Okay. So let's say I have. Now, we can summarize this as, okay, na-compute naman na ito ang electrons sa F na 14. So, we'll also compute the SPD. Okay? So, do not memorize it plainly para di tayo makalimot so that we cannot forget. Don't memorize it plainly. Okay? So, what are the maximum electrons of S? So, kailangan tayo 14. S, P, D, F, okay, 14 electrons man to, no? So, what is S? So, again, remember, 2 electrons per orbital. And we already know how many orbitals in S a while ago in our table. Okay? That is 1. So, 1 orbital. So, cancel. 2 times 1, 2 electrons. Okay, P. So, 2 electrons. So, starting with we see Pauli explosion principle. If you try to understand this formula. Okay, 2 electrons per orbital. Diba? Okay, ganun. 2 electrons per orbital. Times how many orbitals in P subshell or P sublevel? 5. Already there in the table. Okay, so cancel orbital, what's left? Electron. So 10 things that 2 times 5, 10 electrons, right? Okay. This is for D. 3 lang ang atong P. 10 electrons. Because I don't have more. Okay, that's why my memorization somewhere mixed. Okay, so it's better to retain the table. Okay, so that we'll never be messed up. Okay, but in this case, we can easily correct by our brain, right? Okay, 2 electrons orbital, because we see what we wrote. Okay, like that. Times 5. There are 5 orbitals in D. So 5. Muna siya 10. 10 electrons, things like that, okay? 2 times electrons, 5 is 10 electrons in D. So we have 2 electrons times 3 is 6 electrons niya ang P. So, S subshell, S sublevel, there are 2 electrons only that can occupy. P sublevel and subshell, there are 6 electrons only can occupy. D, there are 10 electrons only can occupy. F, 14 electrons only can occupy. Okay. So what's the purpose for this? The purpose of this will be used in the off-board principle. Okay? The lesser the two electrons, the more it will be in the lowest energy level, as what of Bohr principle states, the feeling of electrons, things like that. You get the point? So, withdraw ta atong nindot kayo na something, cherish. Okay? Like that. So, meaning to say, if we have S, our two electrons will be the superscript of the S subscript, S2. Okay. Now, if we have, 6 electrons in the P subshell or sublevel, we will say that as a P raised to the power 6. Okay. Meaning to say, our number of electrons in each subshell and sublevel will become our exponents or our superscripts of our subshells and sublevel. So, D raised to the power, okay, pila man ito nakuha? 10. So D raised to the power 10. Okay. F, we computed it already, raised to the power 14. These four, okay, are the basis of our electronic configuration. Okay. Electronic configuration. Why? This is the arrangement of each electrons in the subshell or sublevel. That is the definition of electronic configuration. The arrangement of electrons in each subshell and sublevel. SPDF. Electrons is 2, 16, 14. No need to go to the Google search just to have the definition of electronic configuration because it's very clear. Here, we can understand. Okay? So, electronic configuration is the arrangement of the electrons in each subshell and sublevel. So, why I said arrangement? Because the synonyms of configuration in English language is also arrangement. So, in this way alone, we can create our own definition without looking books, Google search, whatever. Because our English language is so, is so solid. Things like that. You get the point? That's why we must be having a good English communication skills or good command in English or good comprehension in English so that we can really analyze the English statements in different problem solvings that we are trying to face in the future examinations. There's an advantage really. Okay, you get the point? Sorry to say that. There's an advantage. Okay, you may say no advantage, but for me there's an advantage. I will never details why. Okay, you get the point? So, if you are really good mathematically, if once you are also good in English, bingo. Okay, you got the point. But there are also students not good in math, not only good in English, so more or less they will pass. Okay, you got the point. So, not all subjective, but mostly. Okay, you got the point. Things like that. So you must have both. Okay, mathematical ability and English ability to really climb in the corporate world. Shut up. Okay, get the things like okay, ganon. Okay, basically, I will say math, English plus science. You have this three superiority, then bingo. You might also be successful in life. Together with the right attitude, and proper core values.